talk to you primarily about Azure, platform as a service and backend as a service. But Rob mentioned that a lot of the people around here are .NET developers, so when we get to kind of the mobile portion of it, I'm going to tie this into Xamarin. And if you're not familiar with Xamarin, I'll explain when we get there. First, though, a little bit about me. I've been a technical manager at Microsoft for just about 2.666 years. I had to figure it out today, and it did say 8 months, so I had to do that. I grew up in Michigan, spent most of my life there. However, my family's actually from Indiana, the Elkhart, South Bend area. My grandma still lives in South Bend. She actually was a paralegal, I think, at a bank right by the Marriott downtown here for as long as I know. My parents actually live over in Elkhart now, so it's always great to be back in Indiana and visit the place. Now I live in Washington, though, so I'm here from Seattle, and in Seattle it is about 50 degrees warmer than it is here. So I did .NET development for about 6 years, and then for about the past 3.5 to 4, I've been doing mobile development, primarily native iOS and Android, but I do get around to doing some Xamarin stuff today, so I can at least talk about it like I have touched it, a live bacon, right? So today we'll talk about kind of Microsoft and Azure, just kind of a brief overview of kind of like where Microsoft is at today and what Azure is. Then we're going to talk about platform as a service. Specifically, we're going to talk about Azure websites. We'll talk about backend as a service, specifically mobile services. We'll tie in Xamarin, and then we'll wrap up the end with questions. But you're welcome to ask questions as we go throughout. That's fine by me. So Microsoft today, we kind of have 3 big tenets that we like to talk about, and that is that things are accessible, it's open, and it's easy. And this is Microsoft, but really, at the whole, we're talking about Azure here. As far as accessible goes, there's tons of first-party applications, and these aren't just running on Windows devices. If you have an iPhone or an Android phone, all of these applications, they're available. Azure's not really an application, but all of these things are available and usable from all these different platforms. So Microsoft's no longer a company that really just focuses on building stuff for our own devices. We're building stuff for everything. And everything in general is being open source. So a lot of our development is either using Git internally, or we actually use GitHub. We're going to see some SDKs and use some SDKs today that are all available on GitHub, so you can see them and test them yourself. And then, of course, we contribute a bunch of this stuff to open source. Speaking of which, a lot of the stuff we do that is on GitHub accepts community contributions, so it's not like we're just putting it out there and saying, hey, it's there. We do actually accept community involvement. And pretty much everything at Microsoft, especially through Azure, has feature requests funneled through user voice. So user voice is a really popular way of doing, saying, hey, I think you guys should have this feature or this improvement. And we pay really close attention to what people want to see via that. Yeah.
The user voice is where the whole idea for the safe navigation operator came from, right? Because I remember that was like one of the top ranked things on there, and now it's independent C#6. Right?
I believe so. I'm not, super close to C#6, but I believe so. But for the stuff that I work on for Azure, a lot of the feedback we get and a lot of the new features we add comes directly out of user voice. And it's it's a really good way to say, hey, we'll say, hey, this is coming in, or we're working on this, or that sort of thing. Some of the other open source stuff and some of the maybe unexpected or platform stuff that works with Azure, and we'll see this especially when we look at websites and with mobile services today. We've got support for tons of different languages, not just .NET, though of course .NET works everything we're building. But stuff like Node.js, PHP, Java, ability to deploy open source CMSs like WordPress, Drupal, etc. Tons of different data storage options, not just Microsoft SQL Server, but MongoDB, MySQL, etc. Support for Windows and Linux as far as actually deploying inside of Azure. And then a bunch of different popular management tools. Docker is probably the thing that everybody's heard because nobody can stop talking about Docker these days. And then easy and pleasant dev experience. So as we'll see today, you can build anywhere for Azure, whether you're building stuff on Windows, on Linux, on OS X, doesn't matter. SDKs, pretty much all the SDKs for Azure are all open source. They're all on GitHub. Everything that we kind of build with Azure now is all exposed via industry standard REST APIs. So if we don't have an SDK for something you want to build against, it's all REST, so it's all pretty easy to talk to. As we'll see today, you can choose your own source control for a lot of the different systems. Azure's free to get started, and then by free to get started, I mean there's a free trial for Azure, but then even past that trial, there's a lot of free tiers for most of the services. So everything we see today, you could effectively play around with it forever at no cost. So accessible, open, and easy. So now let's talk about Azure. So if you look at this model here, you see that on the left, this is kind of the typical on-premises data center where you're basically responsible for everything from the the server racks that you're putting in there to the actual servers themselves to virtualization, operating system, the applications you install on them. You really are doing the full stack. You have to deal with everything. And while this gives you the most control, this is also kind of the most expensive in both time and money. The next level up is infrastructure as a service, and this is kind of what Amazon initially made popular, and what Microsoft and Google are doing as well now. But these are basically virtual machines. So you don't deal with the hardware. You basically just say, hey, I want a virtual server that's running, whether it's Windows or Linux, and then you do everything on top of that. So you manage the updating the operating system. You deal with any middleware you want to have installed on that. You deal with any setup. You build the applications themselves. You deal with data. You do with everything except for that hardware layer itself. This is a really popular model, and it's what a lot of people are doing. It's kind of the easiest way to go from using your own data center to doing stuff in the cloud, because a lot of times you can take exactly what you have in your own data center and essentially drop it into Azure, and you don't have to make a lot of changes. However, this is still, again, a fairly expensive way of doing things because you do have to still deal with all the administration of those virtual machines. Whereas the kind of the next level up, which is platform as a service, is in theory kind of the future because all you worry about is the actual application itself, the unit of work. What do you want to build, whether it's your web application or your cron type job or something like that. You don't worry about the runtime that it's running on. You don't worry about the middleware. You don't have to worry about patching the operating system. All you have to do is build an application that is deemed scalable, so kind of usually stateless to some regards, but we'll see how it isn't necessarily true. But you basically just build the application, deploy it, and we take care of everything else for you. So this is kind of like the easiest way to go. And we're going to see two instances of that today, websites themselves, and then mobile services, which is called a backend as a service. That's essentially just a kind of a more abstract version of platform as a service. And then the first idea of software as a service, and this is not really technically applicable to this, but this is stuff like like Dropbox or OneDrive or Google Apps or Office 365, stuff like that. So I think Azure is right now, I think it's still 19 data center regions around the world, and I think as of right now, it's still the largest public cloud in the world. And we're continuing to expand that, as you'd obviously expect all of the other big cloud providers to do as well. But the point of this is that it really is available around the world. So the first thing we're going to look at is the Azure portals. And I say Azure portals because we actually have two different portals for kind of working with Azure right now. There is the that's not what I wanted. Okay. Let me just drag this down. There. All right. So right here, this is kind of the it will be shortly, the full Azure portal. And if you would use Azure maybe about 3 years back, it was basically a Silverlight application. I would deem it to be absolutely terrible because Silverlight, while having its place and being good, was really bad at, when it came to using the Azure portal. Like it just was hard to get around. Whereas here you have this HTML5 and JavaScript portal that still is not exactly perfect. We'll get to an improved portal in a minute. But here we have pretty much everything there is in Azure, whether it's websites, virtual machines, caching, automation, etc. Everything's in here, and everything in this view is kind of component-centric. So you have a bucket for all your websites, you have a bucket for all your cloud services, you have an individual bucket for each component. You don't really have an application view. So if I wanted to look at a website, I could go into that website, but then if I want to look at the database that's tied to that website, I need to go down here and go to my databases instead. So what we've been working on more recently, and kind of the future will be, is this portal right here, which is considered the preview portal. And here, instead of having this, this component-sized view, you basically have an application view. So if you have a website, which we'll create in a few minutes, instead of just seeing the website, you'll see kind of everything that's connected, whether it's a website in a database or a website in a database and several VMs or whatever you want to consider part of your whole application. So instead of having to jump around, it's all kind of contained in one place. We're going to go back and forth between these two portals because today not all of the features are in both of the portals. I think somebody's at the back door if somebody wants to open it. But like I said, we'll go through both of these and use them today as we continue on. So the next thing we're going to talk about is Azure websites. Now Azure websites is essentially a way to deploy a web application into Azure. We like to consider it the fastest way to build for the cloud. This is because you can basically take a web application you're running, not necessarily anywhere else, but close to anywhere else, and you can deploy it to Azure really very, very easily. First thing we'll do is we'll just go into the portal, we'll just create a new website. So for this one, websites is in the preview portal, so we're going to go ahead and use this. So what we're going to do is go down to new, and we're going to go into everything. And there's a lot of different stuff in here. There's kind of like galleries or categories we can choose from. I'm going to choose web for now, and we're going to go down and create a simple website. Create. The next thing we need to access to the names. We'll call this local vars and see if that's available. All right, great, it is. So the next thing is to choose a web hosting plan. The hosting plan is kind of that application grouping. So when I put it in this application grouping, it's kind of going to know where it goes, so to speak. We'll just go ahead and change this to East US because we're kind of closer there than we are to the West US data center. And everything else looks to be about good. So we'll go ahead and create that. So it's going to take a few seconds, and we can see it working there. And behind the scenes, it's doing a bunch of administration and configuration, doing stuff in our internal databases to track this. But really, what's happening is I mentioned infrastructure service and VMs before. When we create a website, it's actually running in a VM. So there's all that stuff that's that if you were doing a VM, you'd have to deal with. But it's stuff that we're taking care of. You just have to deal with building that web application on top of it. So we'll give it just a few seconds, and hopefully it won't take too long to complete. I'm on the Wi-Fi here, so I don't know how good the Wi-Fi is, but if it fails miserably, we're going to have a really rough day. Great, so my website's created now. And one of the things you'll notice when we go through this website that's going to be different when we look at the current portal is this concept of blades. So if we scroll, well, I guess we won't scroll over, but if we look at like settings, for example, every time you click something or when you go further in, it kind of opens up a further blade. That's what they call it. So the first thing we'll do is we'll just browse to the website. And it's going to be just, hey, this website has been successfully created. There's nothing going on right now because I haven't done anything with the website, but we will look at that in just a minute. Yeah. So we've got our website now. The next thing we need to do is decide what we actually want to build. Well, I mentioned before that we got support for a lot of different languages. Specifically for web storage right now, we support .NET, Python, Node.js, Java, and PHP. And we'll go ahead and look right now and kind of see how that support works. So I'll go back into here in the portal, and I'm going to go down to application settings. And inside here, this is really quite simple, and it's almost not worthy of saying it's a demo. But inside here, we can see that our website is already set to be running on 4.5.net. It's going to support 5.4 PHP, Java support is off, Python support is off, we're running on 32-bit, WebSocket support is off, and so is always on. So you can obviously change back to 3.5 if you're running an older version of, well, up to at least 3.5 of .NET. PHP and .NET run side by side, so you don't have to turn on PHP right now. It's automatically running, but you can it's automatically supported, but you can also change the version. Java is interesting, and I will talk about that in just a minute. Well, Java and Python both. As far as the platform goes, by default it's running on 32-bit, but we just can change it to a 64-bit right now by going over to that like that. WebSockets is a kind of a real-time communication protocol that you can use, and again, you just turn it on by turning it on. These are kind of more advanced features though. And then always on is interesting because when you build an Azure website, and we'll see this later on when we talk about mobile services, if it's not accessed for a while, it kind of goes to sleep. This is the same thing you see in IIS in your local data center as well. If your site hasn't been accessed, it's not kind of running hot. It's just waiting to be accessed. You don't have to do anything when you do go ahead and hit that URL. It just takes a few seconds for IIS or Azure in a second to kind of spin things up. If you need things to always be on, you can turn on always on, which is really useful for running processing jobs, which we'll talk about in just a few minutes. Now, Java and Python are interesting because essentially when you turn on Java or when you turn on Python, your website is no longer running to support .NET or PHP. And the reason for that is that we have to actually deploy, for example, for Java, we actually deploy Tomcat or I think it's Jetty. So once you say, yes, I want you to turn on Java, you can then choose, do you want to deploy Tomcat or Jetty as a server? So we basically have to kind of turn off everything that supports .NET and PHP so that you can then run Java. And I want to say that Python is going to be the, I guess you can turn Python on at the same time. So I guess it's just off by default, but that will work as well. So all you have to do is kind of configure whatever you want, and this is going to support those languages for you. So what we haven't done so far, though, is we haven't actually put any code up there, right? This is all great, we support all these languages, but how do we actually get code up there? Well, there are a ton of different options for how to put your code up there. The simplest one is, of course, you can just FTP into the directory and move your code files over. I think we probably all mostly used FTP to move stuff like that before. But Azure Websites has really awesome integration with a ton of different source control providers. So for example, let's say you have an open source web application on GitHub, and you want to deploy from that. You can choose GitHub, you can enter, say this is the repository I want you to connect to, and then websites will automatically set up continuous integration so that whenever you push to the specified branch in GitHub, you'll get a redeployment of your application to your website. Same is true of stuff like Bitbucket, Dropbox, mostly, and CodePlex as well as Visual Studio Online, which we'll talk about Visual Studio Online later if anybody wants to. But what we're going to look at today is we're just going to create a Git repository and use that because it's kind of going to be the easiest way for you to do things. Well, it looks like the recording didn't work, so hopefully this one will be good. All right, so we'll go back to the portal, and I'm going to go back to the first blade we have here, and I will go down to set up continuous deployment. So inside here, it's going to pop this open, and we'll notice that here in this portal, we can choose Visual Studio Online or local Git repository, and these other ones say coming soon. I really have no idea why those are coming soon, because if we go back to the other portal, we can see this exact same website, and we can choose one of those if we wanted to. So all you have to do if you wanted to use GitHub, for example, is go back to the other portal, and actually, let me find the right one. Well, while that's doing that, we'll go ahead and set up a local Git repository.
Top one selected.
Oh yeah, there you go. Well, I already set it up, so yeah. So if I actually go back to the current portal, you can choose any of those other options. They're just not lit up in the preview portal yet. So I've created this over here. I've got my Git repository. So basically what I did was I connected my website to a Git repository running in Azure. So now I can clone the Git repository, or I can connect to that Git repository locally, and I can start pushing changes. But I can also use this as a source control system as well, which is kind of cool. So I'm just going to go ahead and copy my Git URL. Go here. Oh, boom. Oh, that was not what I wanted. Huh. There we go, that's better. It's going to say I cloned another repository because there's no actual code in there yet. So I'll go to, and I'll just create a new index file. So we just added a new index file, I committed it to my Git repository, and I pushed it up. This is going to go ahead and push it up to my Git repository running in Azure. We see some stuff down there where it says it's updating the branch, it's updating submodules, and then it's generating a deployment script. So it's automatically going to deploy this website into Azure into my Azure website for me. So it's going to do that. Now if we go back here and we refresh our site, we'll see we've got our index there. So really quickly we set up a Git repository running for our website, and we can start pushing our code out using a pretty common source control system of Git. And when you look at stuff like GitHub or using DSO, it's even more powerful because you can set up stuff like continuous integration, like run your unit tests before you actually deploy the code, deploy only specific branches. There's a lot of different options you get into when you look at some of the more enhanced source control systems. So this one we'll talk about is scale. So right now I created a website, and it's kind of got its own settings that are basically chosen by what web hosting plan I put it in as far as how it scales. The idea here is that when we create our VM, when we create our website, it's kind of set in a specific setting, and it's able to handle a certain amount of load. But if my website becomes really popular, I need to be able to accommodate that. So for example, I don't know, what's the prevalent term for slash dating these days? Whatever.
Hacker News.
Yeah, if it's Hacker News, or if it's Reddit, if it's on the front page of Reddit, whatever, I need to be able to scale to meet demand. Well, there's two ways we can do that with Azure websites. First is manual scaling. And what we'll see is essentially that exact slider in the settings for our website. We can basically say how many instances or how many VMs do I want running my website. You can drag it to the right, you can drag it to the left. It'll spin up or spin down however many instances it needs to right away. And this gets into how you're build for cost and stuff like that. But essentially you have immediate control into how many instances are running your website. Now that is great if you are sitting by your computer all the time and you have your mouse there and you're ready to scale up and down whenever you might need to. But that's not as easy as, say, having something auto-scale for you. And so what Azure supports is you can specify what sort of auto-scaling you want, how many minimum and how many maximum instances you want, and you can do it based off whatever kind of metric you want. So a really popular one is CPU percentage. What is my CPU pegged at? Say, if it's between 60 and 80, I want you to scale up. If it goes down below 60, scale back down. And you can do this based off a lot of different metrics, whether it's memory usage, disk queue length, data in, data out, whatever maybe the best constraint for your application. So let's go ahead and look at both the auto and manual scale. So inside here, if I wanted to just say if I want to turn auto scale off, I can just choose how many instances I want to run my application. This is the simplest way to do it. Very easy. Then once you actually want to do auto scale, you can add new metrics here if you want to. But for now, we'll just say leave the one based off of our CPU, and we can say between 60 and 80. I want to a maximum number of 6 instances, a minimum number of 1. So essentially, what will happen is when let's say I've got 1 instance right now, and people start hitting my site. My CPU goes between 60 and 80. It's going to say, okay, we need to actually spin up an instance, so it spins up a second instance. When both CPUs are then at that range, it'll then spin up a third instance. And it'll monitor that so that when it drops below the acceptable range, it will spin the instances back down. So it basically makes sure that you're not paying for or using more than you ever really need. So next thing we're talking about is site select. So far what we've done is we're able to push our code out to the web and it immediately goes into production. That's really cool, but most of the time, especially if you're working in an actual company or anywhere realistic, you don't just have a production site, you also have maybe a testing site or a beta site or staging, etc. These are all terms that people use. So site select support this feature. So essentially what you can do is you can start an additional slot and specify one is production and one is our staging environment. You can then specify, for example, our Git repository. You can specify, well, if I push to this branch, go into staging, and don't never go into production because I always want to control when I go into production. So what would happen then is when you push a change, it goes into staging, and then when you're ready, you can actually flip the deployments, and all the code that was in staging will then basically be live for production. And you also get these sticky, basically, settings for your configuration. So it's not going to flip the configuration stuff. So you can still have, for example, your staging connection string for your database set to your staging website, and when you flip those, it won't replace your production one. So you have a really easy way of specifying, this will always be my staging environment, this will always be my production environment, only flip the deployed code. So the next feature we'll talk about is called web jobs. This is a way to run either scheduled or on-demand processes behind the scenes. So whatever you may need to run that's not really UI-centric. So maybe you need to process image data and say whenever I get a new image uploaded, go ahead and create a thumbnail version of that image as well. Maybe it's regular daily data, delete, removal data, etc., stuff like that. Excuse me. So the way this works is that you just specify, you upload a exe, a jar file, a PowerShell script, I think a PHP script. You upload the script and you specify run this you can basically either say run this on demand, or you can specify a trigger. And there's a lot of different ways you can specify triggers. There's an SDK for web jobs, but essentially what you do is in these triggers you can specify whenever there's a new, whenever a new item has been uploaded to storage, whenever there's a new message in a queue, you really have a really good control over what triggers these jobs to run. And once you upload this to your website, it kind of runs for you based on whatever triggers you specify. So I think probably the last feature we'll talk about is Traffic Manager. So one of the, if you're building an application, you want it to be really responsive, or a website, you want it to be really responsive, you never really want to necessarily only have your website running in one data center. Because if my application needs to be used worldwide, I probably want a data center closer to Europe or Asia for people accessing my site from there. Traffic Manager is the easiest kind of way to implement that. And essentially what you're able to do is, again, there's all these data centers, but you can specify your application's running in, for example, 3 data centers. And then you can control either how they should be routed. So if you can use disaster recovery to say, hey, if the primary goes down, start writing people to the backup or the secondary or the tertiary. Or you can also do performance-based. So route people to the correct data center based off what their ping rate is. So basically, anyone in Europe would go to the closest data center to them. Everybody in the US will go to the closest data center to them. And the way that works is it's kind of a temporary DNS provider. So when you go to an application that's running through Traffic Manager, it will reply and give you a DNS record that points you to the correct data center for your website. And you can specify how long that should live for. And the idea there is that the shorter it lives for, the more up-to-date and the more immediate the response will be. So if data center A goes down and you have a very short time to live, then people will immediately start getting routed to a different data center based off that time to live. So as soon as that time to live is up, they'll get a new DNS record. But of course, like everything else, the more it's used, the more it costs. So the longer your time to live, the less cost, because the less time your DNS handler will have to issue a new DNS record. I don't know why the agenda's here, so we'll just skip that. New deck, sorry folks. Tried to combine too many decks today. So we'll skip that stuff. So I lied when I said last feature, because there's a couple other ones I'll talk about that we won't really see in action. As far as backing up your site goes, really, really easy to do, and it can be, if it's connected to a database, you can back up the database at the same time if you want to or not. But essentially, you specify a backup schedule, so once a day, once a week, etc. Your application or your website files will automatically be backed up to Azure storage, and then you can essentially trigger your settings as well, and you can essentially trigger a restore from any source you want to at any point in time. So it's kind of a backup for in case you happen to deploy something you don't really mean to. Although there's actually a really cool thing that I'll show you guys really quickly. If we go to if you actually go look at deployments, I only have one deployment here, but if I actually had multiple, you can actually roll back based off your deployments as well. So if you push a change, if I checked in another git change really quickly and I realized, I did something terribly wrong, you can go into deployments here and go immediately roll back to whatever your previous one was. And that's again if you're not using the slots, which in theory you should use, so that you're never actually deploying directly to production. So hybrid connections are a really cool way to connect your Hybrid connection is a really cool way to connect your websites and later on we'll see mobile services to your on-premises data, whether it's a database, a service, a web service, etc. But essentially what this does is you create a hybrid connection in Azure, you get an exe that you run in your own data center, and that creates a tunnel that you can go through so that you can connect, for example, your website to using a database on-premise. So if your company won't allow you, for example, to store data in Azure, you can still use your web presence, or you have your website hosted there to get that scalability factor, even though it's using your database in your own network. Another cool function for websites is the Redis cache service. Really easy way to basically get Redis as a service connected to your website. So supports really, really cool or really great caching that's really easy to use, kind of built in or easy to connect to from websites. Application Insights is a newer feature that basically gives you kind of like metrics and performance stats on your website. So somewhat of a kind of a similar thing to Google Web Analytics or Analytics. So you can see what the performance of your site is from different places around the world, as well as what the usage is, how many people are visiting your site, stuff like that. So the last thing we'll look at is just a demo, because when I created before, I just created a simple website. But there's a lot of other pre-created stuff or pre-configured stuff that we can also use if we go into the web source. So we'll go ahead and look at that. So I mentioned earlier we've got stuff like, what was it? Joomla here. We go somewhere around here, we'll see WordPress, Django, Cake, a ton of different stuff in here. In fact, let me look for. Yeah. So actually, okay, looks like we've only got that one. So you can deploy WordPress, but you can also deploy scalable WordPress. So if you need a really highly scaled, so think caching is already set up, multiple servers is already set up, multiple, scalable databases already set up, you can actually just pick this from the gallery, and when you deploy it, it will all be pre-set up for you. And there's a lot of these sort of things that we kind of just didn't really look at in full, but a lot of these different things, like whether it's a Node.js starter site, a PHP site, somewhere in here we can see a few different Java engines that are already set up. And so we've got Tomcat and Jetty in here, so you can really easily deploy a full Tomcat or a full Jetty server to a website. So there's a lot of stuff in these galleries for web as well as for virtual machines and some of the other services that are kind of pre-set up for you. So you don't have to worry about, for example, if you're deploying a Windows VM, installing SQL Server on it, you can deploy a SQL Server Windows VM, and SQL Server will already be installed for you. So a lot of different things in the gallery to make it just even easier for you to get started with. So before we move over to the mobile services stuff, does anybody have any questions about websites?
Yeah, I have a quick.
Whoever wants to go first?
What was the difference between the hybrid connection and VPN?
So VPN is more of a, so there's a couple of different like hybrid network options. VPN is more of a, usually, so there's a couple different VPN options. There's point to site, and that's basically when you have I have my own computer and I need to VPN into Azure. There's site to site, and that's where you have VPN hardware on site on premise that will connect to the VPN software in Azure and bridge a connection there. Whereas with hybrid connections, it's somewhat of an easier way, because you don't need any VPN hardware. You can basically, you don't have to worry about the firewall opening up ports. You are, basically manually creating connection between the 2 points. However, there's still options to do group policy control and stuff like that. So it's not like anybody could just, open up a hybrid connection into your on-premise data center as long as they can run exe. It's kind of just an easier way to create that connection without having to go through a bunch of firewall changes.
Gotcha. So you rerun that exe on premise?
Yes. Yeah. So you basically create a hybrid connection in Azure. You get an exe out. You run that exe locally and say yes, connect to this IP address or this server on this port range, and then it will basically funnel all those communications through. So whether it's HTTP, HTTPS, UDP, etc., it'll just funnel whatever you want through. And so it can connect to a database or a web service or anything else you might have, listening in your own data center.
With site slots, when you're switching between staging and production, is there a way that when you basically flip that switch to also run database updates?
I'm not sure if you can attach database changes as well to that. I'd have to look and get the answer for you. Okay, cool. So the next thing we'll talk about is mobile services, and this is where we kind of will bring in the Xamarin stuff. Everything we'll talk about next, though, the interesting thing though is that everything you get out of mobile services is not something you couldn't build yourself using websites, or really, websites is not something you couldn't build yourself using VMs. It's just a matter of time and cost. Using mobile services, you get a lot of stuff that would take both time and money to build in websites. Using websites, you get a lot of stuff that would take time and money to build in VMs. It's kind of a matter of what's more important, building out infrastructure yourself, or building the application or the mobile application you want to give supply to customers or whoever you might have. So Azure Mobile Services is what's considered a backend as a service. And the idea here is, if I'm building a mobile application, or whoever's building a mobile application, I don't really care, or my users specifically don't really care about what's happening behind the scenes. They don't necessarily care about what I'm using to store data, or how I'm doing their user authentication. They just want to use the application, have a really good experience, and feel good about using the application. So the most important thing for an app developer to do is really focus on delivering a positive experience inside their application, and not worry about kind of all the behind-the-scenes stuff. So again, worry about how that infrastructure works. So with Azure Mobile Services, you essentially get a system where you can spin one of these services up, and then you get a bunch of features that most mobile applications will use without having to build them all yourselves. So stuff like data storage. In this case, we're going to see it's powered by SQL database. You have a bunch of different options there. User authentication and data authorization. So easy ability to authenticate users through different social providers, as well as Active Directory, and the ability to lock down who has access to what data. Backend logic, so it's not just a dumb data store system, you can actually craft logic for what happens when you do interactions. Push notifications, really important for all mobile applications. It's going to give you a really easy way to do that. And then backend jobs using something called scheduler, which is kind of similar to what we talked about earlier with web jobs. Just in a slightly more easy to use system. So I'm going to go ahead and create a new mobile service. And normally this is going to be a kind of a compacted version of the normal flow I go through, just because I don't want to spend the rest of the day talking about mobile services since we don't have as much time. So the first thing we're going to do, we'll go back to the portal, and for this I'm going to go to the current portal as opposed to the preview portal because mobile services haven't been turned on there yet. So I'm here in mobile services. I'm going to go ahead and create a new mobile service, and we'll just call this local vars, and good. I'll create a new SQL database, but I could also choose to use an existing one or a free database. I'll put this in the Eastern US data center. And interestingly enough, when I mentioned that Azure is in 19 data center regions around the world, we only see 5 here, and that's because mobile services right now is a newer feature. It's only available in 5 data center regions. But as time goes on, you'll see this. There'll be a much larger list. If you go to VMs, you can see that you can actually create a VM pretty much anywhere around the world. So I'll choose East US, and then I'm going to skip over the backend for now and leave it at JavaScript, but we'll talk about the differences there in a little bit. So next step is I just need to choose a database server. I'm just going to use one that I already created, so I'll enter my credentials. And I will go ahead and kick that off. So now, just like when I was creating websites, I said it was just spinning up VMs or a VM behind the scenes, stuff like that. It's doing some similar stuff with mobile services. Mobile services essentially runs in a runtime that is running on top of Azure websites. So just like how in Azure websites was doing stuff underneath the scenes, mobile services is spinning up kind of a website behind the scenes, putting that runtime there, and then that's what is actually running my mobile service. So we'll give it a few minutes, and there's also creating a new database in this situation as well. And usually this takes anywhere from 10 to 40 seconds, so hopefully it won't be towards the latter. Maybe it will be. Yes,
question
please
about
do.
my website. Sorry.
Yeah, no problem. Please do while we wait.
For session state management.
Yes.
We currently we're using Platform as a Service for our stuff, and then as websites, we're using Redis for the cache. My concern is, I know back in the old days, if you did like SQL with the cache, whereas for sessions, you have to worry about the machine key for encryption. We need to worry about that with websites.
So if you're using a database for your session site, you still have to worry about that same issue. If you're using the Redis, though, I think that stuff is actually there's a sticky setting that's kind of built into using the Redis cache.
Okay, so they take care of it.
Yeah.
Okay.
All right, so that's got created. So we'll go ahead and jump into that. So first page you get is this quick start page, and this is the hey, what do I do now? I'm building my application. What do I do? Now, I'm more familiar, like I said, with the iOS and Android stuff, but today we're going to talk about Xamarin because more people are .NET developers. And if you're not familiar with Xamarin, Xamarin is essentially a technology that allows you to build iOS and Android apps using .NET. It's much, much, much more complicated than that, but at a very simplistic level, you can say, I'm going to build a .NET application and deploy it on iOS and deploy it to Android. As we saw when we look at the code, we actually do have to use iOS-centric, terms and development, and same thing for Android. But what Xamarin does give us is it gives us the ability to actually get a lot of code reuse, especially if you're already a .NET developer and you have .NET resources that work in that code that you might want to use inside your application. So we're going to look at Xamarin today, and what we're actually going to look at is we're going to use an iOS and an Android application, both talking to this mobile service. So I'm going to go ahead and create a new Xamarin app. I've already got Xamarin installed. Next thing I do is I create a to-item table. So when you're using mobile services, you don't need to be a DBA and understand how schema works and all that stuff. But you do need to actually create the tables in your mobile service. And the reason you need to do that is that when we create the table, it actually spins up a REST API behind the scenes that our SDK will use to talk to that table. So the next thing we'll do is we'll just choose Android first, and we'll go ahead and download that. Maybe. When the Wi-Fi doesn't work. There we go. All right. So we'll go ahead and download our application, and we'll go ahead and open it up. now, provided my emulator hasn't died on me. Perfect. All right, so the first thing we'll do is just go ahead and run this application, and then we'll look through some of the code, though. Because of some recent updates to Xamarin, I need to make a few changes to the actual application first, or it won't work. And this doesn't have anything to do with mobile services. It's actually something that Xamarin changed that I didn't know about until today, so it should be fixed on their side before long, hopefully. So if you're not familiar with Xamarin, this is Xamarin Studio I'm running. It's essentially an IDE for doing Xamarin applications. If I was doing development on a Windows machine, I could actually do the same stuff inside of Visual Studio via the Xamarin plugin. I'm on Mac though, so I'm using Xamarin Studio. So the template application that didn't want to work. Let me maybe see what that was. Let me try that again. Let me try restarting that, because that shouldn't happen.
Is Jenny Motion separate from Xamarin?
Yes, so Jenny Motion is an emulator created by Jenny Mobile, but they created an Android emulator that's VirtualBox based, much faster, has a bunch of features if you pay for it that are fairly cool. Xamarin's Android Player emulator is also VirtualBox based, but is just a different emulator. We could talk for days about Android emulators, but that would probably bore everyone. So we'll try and run that again, and hopefully, oh, actually, let's try and start with a different emulator. There we go. All right, great. So basically, the template application you get with any platform you choose. So if we go back here, we can see that we've got Windows, iOS, Android, etc. It's a to-do list. So you create a to-do item table, and you get this pre-built application that's already connected to your mobile service. We'll do that in a second. But we can add to-do items. We can mark them as completed. So we will say fly to Detroit. This is what I did yesterday. Drive to Indiana. Buy a better coat. Really cool. So we've added our to-do items here. If we go back to the portal, we'll get rid of that. We'll go to the data tab. We'll see our to-do item table. We'll go in, and we can see that we've got some data here. Now, at no point did I specify what data field I was going to send up. Mobile Services uses something called dynamic schematization to inspect the data I try to save, and it basically adds columns for us. And it also inspects the data type, so that when I send this data up, it knew that the complete field was a bit field, so it created a bit field in the database. This was a string, so it created a varchar in the database. It has some intelligence to figure that stuff out, so it does the right thing. And if we go back here and we just mark one item as complete, we can now go and refresh the data and see that it's now marked true, so it's done. There's some other columns that are created that I didn't actually send up, but we'll talk about those in just a little bit. So before we actually go into the bulk of mobile services, what we're actually going to look at next is we're going to pull down the same application in iOS, and we're going to try and basically merge these so we actually get some code reuse. So the whole point of Xamarin again is so we can build stuff in .NET, but so we can reuse code. First, let's look at some of the Android application code though. Specifically, we'll look at two different things: the to-do item and the to-do activity. If we look at to-do item, we'll just ignore that. This is basically the to-do item class. This is our strongly typed object. This is the to-do item we send up. So we have a text field, we have a complete field. Text is string, complete is bool, and then we have this ID field. When we actually save this data, the mobile service SDK is automatically converting this up to JSON and sending it to our mobile service. Our mobile service is automatically then going to convert that into a SQL statement for us. But the great thing about that is from the application developer side, I don't understand or have to know how all of those protocols and how that stuff works. Mobile services does that for me.
Quick question.
Yes.
Why did it choose string rather than GUID?
For
ID.
For ID?
Because
It is saying GUID. I don't know if I'm not entirely sure why we have this as a string and not a GUID in here. There's probably a good reason. I'm just not entirely sure why. Code-wise, okay. I'm not entirely certain.
Yeah.
And then we'll see that the Android one has a to-do item wrapper as well, just to kind of make some stuff easier overall in the to-do item adapter, but we're going to skip past that for now. Then if we look at the to-do activity, we'll see one big difference between the Android project and the iOS project we'll look at in a minute. In the Android project, we have a separate class that deals with all the communication with our mobile services. For the Android project, it's baked into our activity. If you haven't done Android development, activity is kind of a the most simplistic but somewhat incorrect way of saying it is the activity is kind of the screen that we're showing on the screen. That's, again, not really accurate, so please don't quote me on that, but that's the easiest way to look at it if you've never done Android development before. So this activity right here is tied to what we see on this on the screen here, and inside here we have a mobile service client. This is kind of our entry point to talking to our mobile service. We then have an iMobile service sync table that's tied to our to-do item type right here. The to-do item adapter. Again, if you haven't done Android, I'm skipping past the adapter, but it's basically how we tie our data into this list view. So down here in the onCreate, so we also have this application URL and this application key. The application URL, this is the URL to our mobile service. If we go to this in the browser, it's just going to say, yep, your mobile service is up and running. There's nothing here because we can't really deploy any sort of web presence for this right here. This application key, though, is something else. If we go back to our mobile service, and we go to the dashboard, we can click on this Manage Keys button, and we see we have an application key and a master key. Essentially, though, when we put the application key in here, and we create our mobile service client with the URL and the application key, all of our requests automatically have that application key sent over as a header. It's into security, which we'll briefly cover in a little bit. So after we create our clients, we initialize our local store. So we'll talk more about offline in a little bit, but essentially the mobile service SDK is built with, at least the .NET one, is built to support offline storage. So behind the scenes, it's setting up a SQLite database, doing the data storage in SQLite, and it's going to support syncing, so in case our application is offline. So after we do that, we can create a sync table with the to-do item. So we set the to-do table type. And then down here, we've got some code for initializing our store. Let's see, what do we get? We're actually syncing the code, so pulling the to-do items right here. Let's see, when we refresh, we call sync, and then we actually refresh the items in our array adapters or from our table. So refresh the actual what's on the screen. We go down here. The last thing we'll look at is just adding a new item. When we add a new item, we create that new to-do item class right here, or to-do object, using whatever text is on the screen, and then we default the complete flag to false. And then we use our to-do table, we call insert a sync, and we pass in that item. And then when we do that, it's actually only pushing the changes to our local data store. So from a developer perspective, you have to control when you actually want to sync to the server itself. So in this instance right here, we're saying insert it and then go ahead and sync it. So go ahead and push the changes to the server and pull whatever changes are done on the server back down. And then lastly right here, we've got, we add that item into our view. So essentially when we go back here and say test, it's inserting the item and then it's calling sync, so it's making sure it has all the latest data locally. And next thing we'll do is we'll actually go ahead and grab the iOS project. We've already got that. We'll go ahead and download this. And it's going to take just as long as before. Try this one. There we go. Okay. All right, so we'll wait for it to restore the packages, and then we'll go ahead and run it. What we'll see here is the application is pretty much the exact same, a little bit more iOS-ier if you prefer. But essentially we've got our to-do list, and because it's connected to the same mobile service, it's going to pull down the data we already saved from Android. So while that's getting started, we'll go back over here. It killed the application because I exited out in Xamarin Studio, but if we run these both, we can say data from iOS, and we'll save that data. And if we go back over here, we can refresh. And so now we've got, both these applications, we've got our iOS, we've got our Android, both going using the same data source. But if we looked at some of the code here, which we're not going to go through very much of the iOS code, but if we look at this QS to-do service, this has a lot of that exact same code that we saw in the to-do activity as far as talking to our mobile service. It's just abstracted into a different class. Don't ask me why the Android one doesn't do this right now. It's something we need to fix on our side. But really what we want to do, though, is we want to combine these two projects into one solution, and we want to use one single class for doing all of our communication with our mobile service. Because there's no point in having all of the same code in two places. So first thing I'm going to do just to make things a little bit easier is I'm going to rename my project so I can add it to my other solution. Okay. Now we'll go ahead and close, or actually we'll reset solutions. So I'm opening back up the Android solution. Again, I just renamed the local var, the iOS one, to be local var iOS. So I'm going to go ahead and add that project into the solution. All right, so we can build everything, and it's all going to feel fine. We haven't actually made any code changes yet. So the next thing we need to do is we need to actually add a project to actually store the shared code between our two applications. So we've got two different options for that, but let's go ahead and go to Add New Project. For Xamarin, we can do a shared project or a portable library. There's a very important difference between these two. A shared project is essentially pulled into the source of whatever project you're currently compiling. So we can basically use if statements in the project to basically, or if defines it rather, to dictate whether we want code to compile if we're doing Android versus iOS, or if we're doing Windows Phone, etc. A portable library, basically, all the code we do in that library has to be supported by every project that's referencing it. So if I use a portable library, I can't use any iOS-specific code or any Android-specific code. There's just no support for it. And as we'll see, hopefully later on if we have time, I don't want to kill anyone. If you're using a portable library, that kind of restricts you in what you can do when it comes to some of the stuff in mobile services. So we'll say shared project. So the first thing we'll do is we'll just add references for that project to our other ones. Now that we've had the references, the first thing we'll do is we'll just add the to-do item class to the shared project so we can get rid of it from both our other ones. So we'll add a new class called to-do item. I'm going to go in here and just take this code completely out. Change that, and now I'll go into my Android project and do the same thing. So now if I compile, everything's going to freak out though because they're all trying to reference to-do item, but nobody has it anymore. So I'm going to add the references to all of these places. All right, so that's now, it will shortly build. So once I'm finished having the references, everything's going to be happy now because everything has a reference to the to-do item class. But no, it's no longer in both of my projects. It's only in one location now. All right, great. So now everything's compiled. I could rerun this, but in the interest of saving time, we'll go ahead and skip that because we've got some additional work we need to do. So the next step is we need to move all this QS to-do service code out of each project, which is really easy from the iOS one because we can just basically take all this code and cut it out of here, and we'll add our new class in here. And we'll just replace that code with what we had from there. Add a few references. So interesting thing when it comes to when I mentioned the shared project and how you can do those define statements for doing iOS versus Android code. This is basically how you dictate to Xamarin Studio what it should know about from those defines. So right now I'm using the Android project. So if I go in here and I say if I've got access to all these Android definitions, right? So I can say, hey, if this is a specific Android API, or if this is just Android in general, then do the following code. But this line right here, because this is something that iOS has to do, I only want to do it for iOS. So I switch the project over to iOS, and then now I can say, if this is iOS, execute that line. So basically now, Xamarin knows that when I compile this application, it's only going to compile that line of code when it builds out the iOS application. So this is how you can use a shared project, but you can still have code specific to each individual platform inside that shared code base. Add a few more references. I think that should be good. Alright, so that builds fine. So now our iOS project is now referencing our shared code. It doesn't have all this mobile services stuff inside of it. The difficult part comes actually divorcing this to-do activity because everything's kind of built into it. And in the interest of saving time, I'm just going to go ahead and copy and paste some stuff or a to-do activity that doesn't use that, or rather that does use the eventually. There we go. Yeah. All right, so now I just need to go into, I just need to add a method in here to actually pull out the client because everything should compile now, and we'll look at the code really quickly. All right, so now if we look at the to-do activity, all the mobile service client stuff's been commented out. Instead, whenever we need access to our mobile service client, we use the QS to-do service, and we call its get client method, which we'll see right here, which will actually comment this out for now because it's authentication stuff. But now what we should be able to do is we can run our application, and it's going to make use of QS to do service, so our shared code for both the iOS and the Android application from both our Android app and our iOS app, but we only have that code's only in one place. So now we actually have code reuse. And the nice thing about this is if we added a Windows Phone application in here, or a Windows application, we can reference that same shared project code and make use of the same mobile service without having to worry about rewriting any of that code or doing anything else. And if we actually go back here really quickly and just say run the iOS app, so this should be running fine as well. Yep. So now we've got code reuse for both our applications. So since we don't have it, exactly a ton of time, I'm kind of just going to talk through some of the other features as opposed to necessarily showing them in action. And then we can have time for questions and more demos later if anybody wants to say later. So basically though, behind the scenes, mobile services is powered by SQL database. That means you get the really rich querying capability of a relational database. You also get that dynamic schematization, so you don't have to create schema yourself. One of the trade-offs of using SQL database is SQL is going to be more expensive than a non-SQL system such as Azure Table Storage or MongoDB. I'll talk in a minute about how you could actually connect to those systems if you wanted to for data that you don't need that really rich querying capability on. As far as data management goes, we were just in the Azure portal and we were able to see the individual data rows. You can also there, you can delete rows and actually delete all the data in a table if you, for example, need just testing and you want to delete all your data. You can't currently add new data or update individual rows. As far as other tools go though, there's a SQL portal, which is a Silverlight application for doing actual database administration. There's the full-blown SQL Management Studio, which is the Windows application for doing SQL management. The same REST API we're using behind the scenes, which we'll look at in just a second, we could use to do more advanced administration if we need to. There's also some CLI tools both for Azure as well as for SQL itself. So this is the REST API that's generated whenever you create a table. So in this case right here, we have our local vars.azure-mobile.net/table/to-do item. And this is common, this is just simple REST. So post, get, patch, delete. Pretty simple as far as doing gets go. That's a OData filter that we're applying there. So everything's very standard. And behind the scenes, we're using just JSON. So the nice thing about this is if you're building an application that you want to talk to your mobile service that we don't have an SDK for, this is just common REST. So it's very, very easy to talk to. This is the JSON to SQL type mapping. So when we pass data in, the mobile service will inspect the data as JSON type and then create the corresponding T-SQL type in our database when we save it. There are some auto-generated columns though. So ID provides a unique ID for every table and every record. So when you say delete this record or update this record, it has an ID to go off of. Create it, update it, and version are all help with concurrency and offline storage. So one of the features supported by mobile services is optimistic concurrency. So if you have multiple devices talking to the same data, and they all basically both try to save data, the default is first write wins. So the second application tries to write the data, winds up getting an error back, which you can either show to the user or handle automatically yourself, but you can dictate what should happen in the case where you say, hey, this data's been updated before you actually read it last. And then there's also support for soft deletes, but that's only enabled, I think, right now in the Windows.NET version, or the .NET backend, which we'll talk more about momentarily. So as far as offline goes, that's actually officially publicly available or production ready for the .NET. So what we're using here for Xamarin, it's official. It's public production ready for Xamarin as well as Windows Phone applications. iOS and Android native, they'll be coming soon. Again, you as a developer decide when you want to sync, and you have to handle sync conflicts. So if you try to write data that is invalid or doesn't succeed, you have to decide how you want to handle that. Whether you just get rid of the data, whether you show the data to the user and say you need to fix this. It's on you as a developer to decide what should happen in that situation. So backend logic. When we created a mobile service, we chose a JavaScript backend, but we can choose between JavaScript and .NET. And essentially what happens is when we create, at least from the JavaScript backend, when we create a mobile service table, it doesn't just create a REST API, it also creates scripts which essentially intercept any request against our table. By default, all the scripts do is say, yep, pass the request through the database, so perform an insert, perform a read, etc. But you can edit these scripts to do essentially whatever sort of logic you might want. Now, for the JavaScript side, these are Node.js scripts, so they're server-style JavaScript. If you build a .NET backend, you essentially get a Visual Studio project, which is similar to a Web API project, and you can do whatever sort of logic you might want there. And we'll talk about that more in a second. So as far as the node size goes, there are modules that are pre-installed that give you access to some really cool functionality from your scripts. So you can use stuff like requests to ping third-party web services or talk to other resources within Azure. You can use push to do push notifications. Console is used for logging information to a login screen. MS SQL can be used to write custom SQL commands as well as store procedures. Tables can be used as kind of a more object-oriented way to talk to the other tables within your mobile service. And then the Azure module gives you access to stuff like table storage, which is a NoSQL storage, blob storage, service bus for doing queues and messaging, and a lot of other really cool functionality. Then there are also partners that have offerings available. So you can send emails via stuff like SendGrid. You can do WebSocket style communications from your mobile service with Pusher. And then Twilio gives you the ability to do text or SMS, voice, fax, all from inside your mobile service. And we don't really have time to walk through this right now, so I'm going to skip this, but I will really quickly show you how you go into the scripts. So inside here, if I go to my data, my to-do item, we'll go to the script column. So here we can choose between the insert, update, delete, and read. All the scripts pretty much look the same. They just call request.execute. But I can do whatever I want here. So for example, if item.text.length is less than 5, we can say request.respond, add request. So I can put in some data validation really easily from my server side. And now without ever having to change the client side, I've got some data validation here. This is an interesting situation though, because if I were then to go into my client application and make a change that did not pass this validation, I'd have a sync error. So that's something where I have to deal with that on my client side. So I'd probably want to say, oh, I should probably maybe show an error to the user and then get rid of that data because it's never going to pass this sync. But really easy to put kind of whatever sort of logic you might want to inside of these scripts. So again, the .NET backend, it's Web API based. You essentially get a Visual Studio project that you can then edit and deploy to your mobile service. For the Visual Studio for the .NET backend, you essentially get a table controller, which gives you a really easy way to talk to the tables you have stored in your mobile service. But you can also map really easily to table storage, Mongo database, etc. As far as you can pull in NuGet modules. So just like with the Node stuff, you can pull in Node modules. You can pull in NuGet modules so you can make use of other code that's already out there as part of NuGet. We'll talk more about permissions and authentication in a second, but you can set up permissions on your different table operations via attributes. And one of the nice things about the .NET backend is you can actually locally debug it. We don't really have a good story about that for the Node one today, but for the Node version, you actually get the F5 experience in Visual Studio where you can run your .NET backend locally. So there's also something you can do create called custom API. And these are basically non-table based endpoints. So everything we did right now was tied to a specific table and had that request to execute in it. These are scripts where you can define whatever functionality you want for get, post, put, patch, and delete. And just like the other scripts, there's no request that execute because there's no request being done. You dictate whatever logic you might want. And you get the same security you're going to get on the table, which we'll see in a minute. As far as file storage goes, you can skip reading most of this, but essentially you never want to store essentially large byte data inside your SQL database because SQL is costly and that's a bad idea. But using that Azure module from the Node backend or using the .NET SDK from the .NET backend, you can really easily talk to blob storage and then make it possible to start storing blob data, large amounts of data into blob storage. And the same would be true of table storage. If you have data you don't need the huge queryability over, put it into table storage using either the .SDK or the Azure module, and then you don't have to worry about using all your SQL storage. So as far as push notifications go, it doesn't really matter what platform you're building an application for. It's all the same. You've got a client that talks to a push notification service. So in the case of Android, you're talking to probably GCM or Amazon Device Messaging, Baidu. For iOS, you talk to APNS. For Windows, it's WNS, etc. The push notification service then gives you back a token and a registration ID, some piece of information that identifies your app and your device to them. You can then give that information to your mobile service, who can basically then talk to the push notification service and say, hey, please deliver this information using this token. So what mobile service essentially gives you is a really easy way to both send that token up to your mobile service as well as connect it to tags. So you can register your device to get push notifications and tie it to tags that you might want to push to. So a tag might be something like your username, your device type, etc. So then you can say push to all of Chris's devices, or push to all of the Android devices, or push to a specific device itself. And unfortunately, we don't really kind of look through it, but essentially behind the scenes, mobile services uses something called notification hubs, and that is a push notification service, or not push notification. That's a push notification system that will deal with doing push notifications to Android, iOS, Windows Phone, and it's completely separate from mobile services. Mobile services just uses it. But if you just need a system to actually deal with all of the server-side crap of dealing with push notifications, notification hubs will deal with signing your request for certificates, dealing with the API keys, dealing with bad pushes, because if you perform a push that APNS doesn't like, it will tell you about it, and if you keep doing it, it will not let you push anymore, so you don't want to keep doing it. And notification hubs will deal with that for you. It gives you that tag system, so even if you're not using mobile services, you can use this to do a targeted based push, so push to a specific user, push to a specific interest, etc. And templates as well for doing cross-platform push without having to specify payloads for each individual format. So as far as data authorization authentication goes, right now all we're doing is, as I mentioned before, when we created our mobile service client, we did it with the URL and the application key. So all of our requests included the application key as a header. So the default security level on mobile services is that you have to pass in the application key. That's really great and perfect for, I'm not, my app is not publicly available yet. But once your app is publicly available, it's pretty trivial to disassemble your application, whether it's a Xamarin.net application, an iOS application, or an Android application. Pretty easy to disassemble that and essentially find out what this key is. So once you're ready to go to production, you really want to look at other security methods. So the easiest one is just say everyone can access the API, and this would be something where the data is public. You don't care about security necessarily. Authenticated users, though, is the easiest, kind of the best option if you actually have authentication with your users. You can then tie a user to every action they perform, and all your requests will get a user ID and a token that corresponds to that user. And then if you want to lock a table or an operation down, you can set it to admins and other scripts. So only somebody with a master key, which was the other key we saw earlier, or a different script, so on your server can access the table. As far as user authentication goes, mobile service has built-in authentication with Google, Facebook, Twitter, Microsoft accounts, as well as Azure Active Directory. And if your company uses Active Directory, it's pretty easy to actually sync your Active Directory on-premise with Active Directory in Azure. So there's two different flows of authentication. The server flow is basically where your application uses the mobile service SDK to open up a web view, which goes to a page in your mobile service, which redirects you to whatever the authentication provider's login page. So you are the URL for your mobile service, and it actually redirects that web view to, for example, Twitter's authentication page. User authenticates, the provider hands the token back to your mobile service then. Your mobile service then creates an identity, so a user ID and a token that authenticate with your mobile service back to the device. And then all your future requests from the device will have those credentials with it. When you do that, you then have graph access from your mobile service, so you can do stuff like, tweet on their behalf or access their friends list, provided you've requested the correct scope or permission from the provider. The other flow is the client, and this is where you use a native SDK, so for example, the Facebook SDK, to authenticate the user. This is really handy on stuff like, for example, Android devices, where you can use the very familiar, pick your Google account, which is, just a very native UI element as opposed to a web view. So it's really useful for that because people are used to it and they don't have to then type in a password. But essentially, you authenticate with that native SDK, your device gets back the code and the token. You then pass that information to your mobile service, who verifies it and creates your identity. And then in that situation, both the device and the mobile service have graph access. So the user object is something that's passed into every script call. When you're not authenticating, all it says is you're just anonymous, doesn't give you any information. Once you're an authenticated user, though, you get back a ID, which you can then tie basically data that you saved to a specific user. And I'll show you really quickly how to do that in a minute. You can also then get additional information, depending on the provider, so the person's actual name, their locale, not really their location, profile URL, etc. So I'm not going to go through the full auth stuff because we definitely don't have time, but really quick, we'll look at a couple pieces of it. So I'm going to go to the permissions for the to-do item table, and since I created the to-do item table via that getting started thing, it didn't give me the option. But if we were to create a new table, it would give you the option of specifying all these in creation. But if you wanted to lock your table down to authenticated users, you just say only authenticated users can do this. One of the great things is, like, let's say you have data that you want everyone to be able to read, but not everyone to be able to edit. You can change, just the read permission to say everyone can read the data, but only authenticated users can insert it, or only admins can insert it, for example. As far as actual authentication goes, from the client side, there's very little you have to do. There's a login method in the SDK, and you say, I want to log in with Twitter, or I want to log in with Microsoft, or Google, etc.
When you change those table permissions, so you say anyone that's logged in, do you get like a log, an audit log? It's like, so whoever modified the data last kind of thing?
You don't get that by default. You have to do that in the script yourself at this point.
Okay.
So we'll just back out of that. The one thing you have to do on the server side, though, is you have to set up an application in whatever the development portal is. So, for example, if I'm setting up Twitter authentication, I go to their app page, which is right here, and I create a new app, which I'm not going to do, but you enter some information, and you enter the URL of your mobile service, and you get back an API key and secret. Once you paste that information in here and save it, then you can then use your mobile service to do Twitter authentication. And that way, when you authenticate, Twitter knows what application it should be talking to, so it knows where to hand back that token and that secret to. Yeah. So command line interface, I mentioned this briefly before. But there's an Azure CLI, which there's a node, there's a cross-platform node library, and there's also a PowerShell library. but it enables you to do stuff to create and delete new mobile services, look and delete your tables data, create, update, delete table permissions, pull down, update, delete scripts, scale up and down your services, and it lets you do a bunch of other stuff across Azure, so it's not specific to mobile services. You can do all sorts of stuff with websites that we saw earlier, as well as with VMs, etc. We'll kind of skip that. We'll skip the scheduler. Basically, you can create scheduled jobs or scripts. So just like the script we saw earlier, you can create a script, whether run it on a schedule or run it on demand whenever you want to. By default, script source control is turned on. So when I created my Node.js mobile service, it created a Git repository. I can clone that Git repository and I'll get access to all of my scripts, so table, custom API, scheduled scripts, as well as JSON files corresponding to their permissions. So what that allows you to do is you can basically edit all of your scripts locally and then push them up. This is also a really great way in case you want to have a test mobile service and a production mobile service. You can push changes to your test mobile service, and then once you know they're ready, you can then trigger them actually push them to the production as opposed to trying to make manual changes. Using the script source control, this also enables you to install NPM modules, so you can reuse a bunch of modules that are already built for Node. It also allows you to create shared scripts, so you can create functionality in a shared script and then use it from all of your other scripts. So if you have common functionality, you don't have to write it in tons of different places. You can have it in just one place and reuse it. As far as diagnostics, logging, and scale go, you get some simple information like the number of API calls, the number of devices, and the amount of data out. That's important because the API calls is kind of how mobile services scale. There's a console tab for looking at logging, whether you log information yourself using the console module, or if you have errors you're not catching, will be logged automatically. There's a free tier for both mobile services and SQL, and there's a free tier for websites that we looked at earlier. So websites, mobile services, you can effectively play around with to a limited degree forever and not have to pay for it. And of course, mobile services also has auto scale. It just, actually, I think we got rid of auto scale because it didn't make sense. Hold on, we'll look at it in a second. So as far as mobile service scaling goes, the free tier is 500,000 calls, and then after that, there's basic and standard, and you get units, so depending on how many API calls you might be using. And there's a per unit cost for each of those. So really quick look at those different features. So we'll go up here. We don't have anything logged right now. If we logged any information, it would show up here. This is where you could log information on auditing, table access or table changes. But this isn't the best place to put something like that because that would probably be a lot of data. So you probably want to put it somewhere else, like table storage, for example. As far as scale goes, we'll go into the scale tab. Currently, I'm on free, but once I go up to standard, I can choose how many units I want to support. So how many API calls essentially. And we can also set up auto scale for this so that we are not, so you can set up auto scale based on the API calls, so you won't be using more, you won't pay for more units than you actually need. Similar to websites, it will only scale you up when you need to, but this is based off usage as opposed to that being based off, for example, CPU percentage or some other metric. All right. So sorry that was kind of a rush through that. I guess I didn't plan that for time as well as I'd hoped. But again, Azure Mobile Services is a backend as a service, makes it really easy to build a mobile application where you can focus on a good client experience as opposed to worrying about all the infrastructure and stuff of what should happen on the server side. You get access to data storage, authentication, authorization, logic, push notifications, as well as scheduled jobs. You can find all the information I've talked about as well as a ton of other stuff on azure.microsoft.com. Specific to mobile services, if you go to azure.microsoft.com/mobile, that's where all of the tutorials and walkthroughs for mobile, whether you're doing it in Xamarin, or iOS, or Android, or Windows Phone, etc., they're all there. All of the Azure Mobile Services SDKs, so we actually had in the Xamarin project, they're all open source on GitHub, so you can actually go and understand how they work, etc. As far as websites, there's not really a websites SDK, but there are obviously SDKs that you can use for other aspects of Azure from those websites. They're also on GitHub as well. You can always reach out to me if you have questions about websites, mobile services, or anything else related to Azure. And I think that's probably enough, so I'd be happy to answer any questions. Yes?
So you showed us the .NET implementation for mobile services. I also saw JavaScript and separately PhoneGap. The JavaScript one, does that create a native app in some way? Or is it a website?
So the JavaScript SDK, so what he's referring to is if we go back to our inside here and we go to the quick start, So we have HTML JavaScript here. So essentially what it is, it's a JavaScript library you can use to talk to mobile services. And you can use that in two ways. You can use that as I'm going to deploy a web application, I'm going to use JavaScript to talk to my mobile service. Or you can deploy that into like a phone gap style application. So, it just makes that easier to do from a phone gap style app. So
Or potentially you could make a website out of it.
yeah, absolutely.
Okay.
Yes.
Okay.
Absolutely. You can also use the .NET one to use it from like a ASP.NET application as well, but you can totally use that from a web application as well.
Okay.
Any other questions? Yes, sir.
Actually, let me find my note that I written on here. So, mobile services, you mentioned that you can have it be open to everyone, authenticated users, or only admins with a master key. But is that master key not sent as a header like the? I mean, that seems like that would be really easy to man in the middle, or is it HTTPS?
Absolutely. Absolutely. So the idea with the master key is that's not something you want to ever put in an application you'd release on, for example, an app store. Because again, just like for the app key, once it's in the store, you really don't, anybody can really get to it if they're dedicated enough. So the admin key, the master key would be more like, hey, I'm going to build an admin application that I'm going to deploy to my device, or I'll deploy to the 3 people at my company. Something like that, where I'm only going to deploy this to people that reasonably could get the master key from logging into Azure anyway. Essentially. So yeah, that master key is not something you'd put in a public application. And one thing I will skip while anybody that thinks of any questions they might have is how you actually lock down the data. So you can obviously change the permissions and say only authenticate users. But what especially for the to-do item application, for example, what you actually want to do is say only, Chris can only access Chris's to-do items. So there's no way, there's no automatic way of saying, hey, tie data that I saved to me. Essentially what you end up doing is making a change in the script. So before you save the data, you would say user ID, user ID. So now whenever I save data, since I'm sending in a user ID, it's automatically going to be tied to my user ID. So this will automatically add that property to my item before it goes to the database to be saved. Then the next step of that is making sure I'm only seeing the data I should be able to see. And for that, you go to the read script and you say query.where user ID, but user ID. So that's going to automatically change the query whenever I try to get data. So basically say only query the data for my user ID. So you could also make these changes from the client side because you're specifying, you could add the user ID to the to-do item before you save it. You could add a new query from the client side. But just like you don't trust that the application key is not, is not secure, you don't trust that somebody can't access some of the application and change what you're querying or change what you're saving. So when you change it from the server side, you know that now, user 1 is only seeing user 1's data. They can't change that because it wouldn't show up as an authenticated user. Any other questions? Yes.
A completely unrelated to mobile question.
Sweet.
In your first slides, you mentioned that you're doing stuff with Docker.
Yes.
And I was wondering if you could talk for just a minute about what Azure's plans are for doing things like some of the Amazon's got container service in beta now, and Lambda, which is more like a platform as a service, like you're just running little statements stuff in response to events. And I was wondering if you could tell us about what Azure has in the pipeline along those lines.
I actually cannot, mostly because I don't know, and partially because what I do know I'm not allowed to talk about. I do know we have plans on those lines. Specifically for Docker, we've got, we're working on adding additional support. So we've released stuff into the Docker open source framework. I think the last time I checked, we were just waiting on pull requests to accept like a PowerShell command utility for controlling Docker, as well as other tooling for it. So we're working to make that easier to do from a Windows perspective, and with Azure, like we've got a bunch of. I think if we go into the preview template and go to virtual machines, there might be something set up. Yeah, like we've got some Docker stuff already set up in here, but since we support. I didn't really highlight this, but since we support all these different Linux images inside of Azure, you can definitely use Docker with Linux, but I can't talk to our more containerized plans, I guess. Good question. All right. Well, sorry I kind of tried to whirlwind through everything. Next time I should probably cut it down a bit. I hope everybody enjoyed. If anybody has any other questions, you can come follow up with me or come up and talk to me or whatever you guys want. Thanks everybody for coming. I appreciate giving me the opportunity to come and present to you guys.
Thank you.